Okay, now we are going to continue our revision to the question number 6. Question number 6, yeah? Yesterday is question number 5. So question number 6 is this. A circuit consists of an AC supply and two lamps. The lamps are connected in parallel. Draw the circuit diagram. Okay. So consists of two lamps which is connected in parallel. AC supply, the AC is like this one, like a sinusoidal, and then consists of AC and then resistor connected in parallel, or lamps, yeah, sorry, it's lamp connected in parallel. So this lamp, first lamp and the second lamp is connected in parallel. Okay, the electromotive force of the AC is 230. When connected to the 230, the resistance of one lamp is 1200 ohms and the other is 800 ohms. Okay, thus one is 230 volt. Calculate the current in the 800 lamp. 800, there was the current in 800 lamp. Okay, as we know that this has different kind of current, yeah, different kind of current. We can use to find the current in 100 lamps using very simple way, yeah. Okay, so we know that the current is V divided by R. Okay, so the V is 230 divided by the current, the R, the resistance is 800, because in parallel circuit the voltage is the same. Okay, so we just divide 230 divided by 800, which is 0.28 or 0.29 ampere. This is the current that flowing in the 800 resistance. So let's say the current flowing here goes there, okay. So we're going to prove it. How about the current that flowing through 122 ohms is V divided by R, which is 230 divided by 1200 is equal to 230 divided by 1200, this is 0.2 ampere. If we want to calculate the total resistance is 1200 times 800 divided by 1200 plus 800, which is equal to 690000 divided by this one is, yeah, 2000, so 3 which is 960 divided by 2, yeah, 960 divided by 2, which is 480. So the total current is equal to voltage divided by total resistance divided by 430, which is equal to 230 divided by 480, this is 0.479 or roughly 0.48 ampere. Okay, so if we add this to this, we will get almost the same answer. So the total current, okay, the total current is the current blowing in the 1200 ohm plus the current blowing in 100, which is equal to 0.2 plus 0.29, which is equal to 0.49. It's roughly like the same. Okay, that's because we round up this first, so that it becomes like this. Yeah, I think the simple way is this you want to find. So the concept is that the voltage across the voltage in a parallel circuit are the same. So this voltage is the same with this voltage across this resistor. Yeah. So the voltage are the same. Next one. Calculate the energy used by the 800 ohm lamp in 5 hours. Give your answer in kilowatt hours. So the energy across the 5 hours, across the 800 lamp is equal to VIT, vitamin, yeah, which is equal to, we know just now that the 800 has 230 volt times the current in the 800 is, just to remember that, 0.29, yeah, 0.29. So we just times them. 0.9 times the time 5 hours. If we convert 5 hours to second, then you will get 18,000 ohm, 18,000 second. So 18,000 times 0.9 times 230, which is equal to 1.2 times 10 to the power of 6 joules. So that's the answer. Calculate the combined resistance of the two lamps in the circuit. I have answered that this is the combined resistance. So if there are two resistance in parallel circuit, so the combined or the total is R1 times R2 divided by R1 plus R2. In the condition where the resistance, where the resistance is connected in parallel, but only two resistance. So this first resistance, the light bulb is the same like resistance, and this is the AC supply. So this is R1, this is R2. Yeah, the answer is 480 ohm. The next one, number 7, shows a circuit diagram. Design the switch on a night light when the surroundings are dark. Draw a circuit symbol for a voltmeter used to measure the potential difference across the light-dependent resistor. Which one is light-dependent resistor? This one is LED. This one is light-dependent resistor, and we draw the voltmeter across it. So this is the drawing. State the effect of this change on the resistance of the LDR. State the effect of this change on the resistance of LDR. Okay, the effect is that decreasing in the resistance. Next one, state and explain the effect of this change on the potential difference across the light emitting diode. Because of that, so that the PD, the potential difference, will because the resistance is decreased, so it will also decrease. The next one, the current supplied by the power supply is 0.5. Calculate the resistance of lamp A. This is identical, yeah? The current supplied by the power supply is 0.5. So this one is 0.5 ampere. Deploying here. Calculate the resistance of lamp A. So yeah, the total resistance of A and B, the total resistance of A and B is R times R divided by R plus R, which is half of R. So resistance is V divided by I is equal to 240 divided by 0.5, which is equal to 240 is 480 ohms. 480 ohms is AB. Okay, so because AB is a half R, which is a half R, so the R will be 480 divided by half, which is equal to times 2, 960, right? 960 ohm. Next one, number 8. A washing machine has an electric motor and electric heater. The heater has resistance of 25 ohm and the power supply has an electromotive force. State the meaning of electromotive force. Electromotive force is the energy required to move a charge, or in a simple way we can find that energy is electromotive force, which is voltage. It will be the same with voltage. EMF voltage is equal to energy required to move a charge. State the potential difference across the heater. This one is heater. This one is motor. Okay, so the question is this voltage is what? Because this one is in parallel and we know this one is 230, so the answer is 230 volt. Because in parallel the voltage is the same. Calculate the current in the heater. The current in the heater. So what's the current in the heater? We know the information is that the resistance, the heater resistance is 25 ohm, 230 volt, this one, and that's only the information that we get. And there is a motor there. Calculate the current in the heater. The current in the heater. Okay. So this one is 230. The heater has a resistance of 25 ohm. Okay. So of course voltage divided by uh, the current is voltage divided by the resistance, because the voltage is 230, so we divide by 25, which is equal to 230 divided by 25, which is 9.2 ampere. And then for the current in the motor is 1.6. So what's the reading on the meter reading is the sum of this, which is 9.2 plus 1.6, it is 10.8 ampere, because total current is the sum of branch current. Branches current. Okay. Current. Next one. Number 9. A car with windscreen is covered in condensation. The thermal energy is used to remove the droplets of water. The thermal energy is provided by three resistors on the windscreen. The three resistors are identical. That is, one is identical in this. Describe the advantage of using circuit B. The first one parallel is if one break or broke, another still work. If this break, so another still work. Okay. And the other one is that in the parallel circuit, we get more power, yeah? Because the voltage is the same. The next one, describe in terms of the water particles the process by which the water droplets are removed from the car windscreen using the heater. This is evaporation, yeah? This is the evaporation. So the evaporation takes place when the more energetic particles escape from surface. This is what we call with evaporation. Next one, calculate the current in the resistor Q. Circuit containing two resistors P and the circuit powered by a 12-volt battery. Calculate the current in the resistor Q. So as usual, that 12 volt, 12 volt, 12 volt, then the current will be 12 voltage divided by resistance. The current, which is voltage is 12 divided by Q, 70. So 12 divided by 70, which is equal to 0.17 ampere. Calculate the energy transfer electrical when the current calculated in B1 is present in resistor Q for 5 minutes. Calculate the energy transfer electrical when the current calculated in B1 is present in resistor Q. So this current is also in the Q, yeah, for 5 minutes. So energy is vitamin. Okay, so vitamin. So the voltage across is 12 times the current is the same, 0.17, and then 5 minutes is 300 seconds. So yeah, 12 times 0.17 times 300 is 612 joules. Next one. Energy is transferred from the battery by the electrical current. Instead, the energy stored in the battery. Oh, we call it chemical energy. Chemical energy. Calculate the total resistance of the circuit. Combination is, I have many times said that this is the very fast formula, which is R1 times R2, 90 times 70. So 90 times 70 divided by 90 plus 70. 600, yes, this one, and this is 160. Yep. So 6 divided by 160, which is 39.375 ohm. Okay, I think this will help you to answer the question. Thank you. Goodbye.